It's been sitting outside for quite a number of years, as you can see. It's just been dropped off, and it's going to take a bit of work to get it up and running. But it should be quite interesting, quite useful once it's done. But as you can see, it needs an awful lot of work to make it really serviceable. But if you're interested in this sort of thing, then let me know. I'll include a few videos as I go. Because this machine had been parked out in the sun for probably over a decade, it's suffered some severe UV damage to certain plastic parts. So this is the front of one of the headlights, and you can see this wouldn't really do much good as a headlight. It won't let much light through. So what I did, I made a fixture for my lathe, and because these are moulded, they're slightly tapered, so I made a fixture these would fit onto. Quite brittle plastic, of course, as it's been aged by the sun. And then I machined off these front faces of the housing, and then I fitted some clear discs to the front, bonded those in place, and then put them back in the lathe once it's set up, and just rounded over the corners. So now they're nice and clear, and they can be put back onto the reflectors, and I'll get some nice bright headlights. So that's another job done. Couldn't really find any sensible replacements, and this will work just as well. One of the problems I had with this machine when I first started trying to drive it was that it was almost impossible to get it to go into gear. You could just about manage it, but it took a huge amount of force on the gear stick to the extent that that was a bit where I was going to break something. And that was partly due to corrosion on the various linkages. When I drained the fluid out of that rear gearbox, there's a gearbox down here, and there's another gearbox attached to the engine, and then you've got the rear axle. But this gearbox, when I drained the oil, it was just basically sludge, and I assumed that the inside of the gearbox was completely rusted up. I've already shown the internals of that. It actually cleaned up quite nicely, but it still wouldn't change, and that turned out to be the indents, springs and balls weren't in the right place and were too tight. But then it got fairly interesting. It's quite hard to explain, but if we look down in here, you'll see that you've got these two. This is the bottom end of the two shift cables, and this slide we're looking at, the one closest to us, is for selecting reverse. And the way you're supposed to adjust this is to put the gear stick into a neutral position, and that should engage the indent balls that are at the gear shift end. And then you need to align these ends of the selector cables so that the gear box slides are also in neutral, and it was impossible to do that with this arrangement. It can never have worked, because even where it is now, the cable is set to its absolute shortest limit, but this link here, the one I'm just pointing at, was down here somewhere. It's about probably 3/4 of an inch too long, so it was always trying to partly engage reverse, even with the gear stick in the neutral position, which of course engaged the interlock within the gearbox, which I'm assuming is why the interlock balls had been kind of popped out of place. So all I did was to shorten this selector rod on the gearbox, align everything, and now what was almost impossible trying to select gears, you can now do so quite nicely with hardly any force at all. So that brings us on to the next part of the problem, which was I've been chasing various electrical gremlins in this, and I removed a lot of extra wiring, as we've already seen. But the speedo wasn't working. It always just sat at 0, and there is no speedo cable on this. It's an electronic speedo, and it's supposed to take pulses from the ignition control system, which is a box that sits down in the bowels of the machine. So there's a pulse from that each time there's a spark, single cylinder engine. Each time there's a spark, it sends a pulse to the speedo, and it's supposed to show the speed. But the question is, how does it know how to interpret those pulses? Because it's a 2-speed gearbox, it's got high and low ratio. So there's also a CVT gearbox attached to the engine. So kind of strange that I couldn't figure out how it would know which gear you're in. So how would it know how fast you're going based on engine speed? And then I found this connector. I actually moved it and brought it up. It was cable tied right down underneath. And also on the top of the gearbox there were some micro switches. They're all smashed to pieces because obviously it's very vulnerable down there, and small things like micro switches, that's not the place to put them, they just won't last. But this, as it turned out when I did some tracing, depending on which of these pins you ground, it will turn on an indicator light on the dash to show low ratio, high ratio, reverse or neutral. And also there's a link wire being put on the starter solenoid to bypass the kind of normal protection you get to stop you cranking the engine when you're in gear. And this all works together, and because this feeds into the control unit on the display, I'm assuming that this arrangement is also supposed to be used for the control unit to figure out what ratio the gearbox is in, so whether you're in high or low or reverse, so it knows how to interpret the pulses from the engine to show the correct speed. Haven't tried it yet, that's just a guess on my part, but what I've done, because I didn't want to put these switches back and just replace them because they just get smashed again, it's a silly place to put them. So what I've done, just raised the seat. Is I've made up, it's probably hard to see, just get a torch. So I've made an arrangement that fits in down here. This is the top end of the selector cables, and it's the same sort of arrangement with regard to the micro switches, but obviously it's protected up here. It's inside the machine, so it's not going to get hit by stones and mud and whatever. But it works in the same way that I can now wire this up to give the correct indications and signals through to the control unit, and hopefully that will then allow the speedo to start working. The bypass can be taken off the starter solenoid, so it will now only crank when it's in neutral, at least that's the plan, and it will also show the correct indications so I'll know which gear it's in. That's the plan anyway. I haven't wired it up yet. I'm just going to figure out exactly how to get that wiring sorted out, but hopefully that will get it working the way it's supposed to. As I've been working my way through the various faults I found on this, come across a few strange ones. The first was that it's once I got it running, it always seemed to start very easily, and it would idle and drive quite nicely. And after I'd been running it around for sort of 10-15 minutes, I had already topped up the oil in the engine. I decided to give it a proper oil change, and now I'd got it all flushed and loosened off all the dirt. So I did. I drained the oil out, topped up the oil to the correct level, so you've got a dipstick down here, so that's this thing, and it says here how much to put in. And the clue here is, if you look at the angle this text is sitting at, I didn't really notice this to start with, but I topped it up to the correct level on the dipstick, but when I tried to start the engine after that, it wouldn't start. There's no spark at all. Now I don't know what the arrangement is in here exactly, but what we've got are some cables coming out the top. 3 of them are for the generator, they go through to a rectifier and regulator. And then 2 of the wires coming out here are the pickup for the spark. So there are no points in this. It's a small pickup coil attached somewhere to the magneto, and that is used to decide, or to allow the unit to decide when to spark. So I'm assuming it's something that happened in there that it's interfering with that. I put in the right amount relative to the dipstick, but then it would not spark at all, and I even tried a new spark control unit, and it just would not spark. Checked all the wiring was fine, but it wouldn't spark. So I sucked out about 100 millilitres of oil and tried it again, and it started. And it's been fine ever since. So there's something in here that seems to interfere with the spark if you put too much oil in. And that comes down to, as I said, the angle. If you look at the angle of the engine, it's tilted down quite a bit towards the left. And this is meant to go in a motorcycle, really. It's kind of a scooter type engine, 300cc single cylinder. But obviously the designers of the engine assumed that when they design the dipstick that the engine will be filled up while it's level. And the problem here is because it's tilted, then I'm suspecting the wrong amount of oil was in there. And what I've done now is I've remarked the dipstick so that when I put the correct amount in, which is written on there, 1200 millilitres from empty, then I know exactly what the level should be on the dipstick, and so I can keep it topped up to that level and hopefully avoid the same problem again. I had a very similar problem with the gearbox, the rear gearbox, in that it is also sitting at quite a steep angle, and I topped that up when I had it on the bench after I removed it. Again, there's a dipstick down here, but when it was on the bench I topped it up to the correct level according to the dipstick with the gearbox level, which is of course how the manufacturers would assume it would be used. The vehicle manufacturers of course don't make this. This is kind of a generic Chinese gearbox. But when I put it back in the machine and checked the level on the dipstick, it was massively overfilled. It was almost coming out of the hole, and that's simply because the dipstick hole is at the back of the gearbox, and the gearbox is tilted at about 20 degrees, so all the oils run to the back, and it looks like it's overfilled. But more importantly, if you only fill it to the level on the dipstick, it will only have about half the amount of oil in that it should have. So that's another thing to bear in mind if you've got a gearbox like this, is take into account the angle that it's sitting at. Also, you can see I removed the switches from this. Not surprising, they got broken, very exposed down here, so not a good place for them. Everything else has just really been a case of cleaning and lubricating. So the prop shaft, it's supposed to be a spline down here, and that was completely seized up. So took that apart, cleaned it, greased it, and hopefully now that will slide without putting too much force on either the engine or the gearbox. So getting there, it's still a fair number of jobs to do, but we're starting to get to the point now where I can start to get things reassembled. So another problem I had with this was the tailgate wouldn't open, and the problem was it had some plastic hinges that were part of the moulded tailgate structure, and they sit on a couple of pins. Some pins go through the this metal frame that the tailgate, or rather the entire tail structure is made from, and it's got plastic coverings on it. But it rusted solid, and when the tailgate had been opened at some point, it snapped off the hinges. So what I did was make up a couple of aluminium hinges. This is just a test one I was experimenting. So 2mm aluminium plate, and just folded round using the press, and then that sits, you can't really see it, most of it's hidden now, so that was slotted down into the base of the tailgate, drilled and bolted, and then there's a right angle bracket. You can see the tip of that comes up and onto the internal structure. It's much stronger than the original, but I don't want it snapping off again. And this now opens and closes nicely, so that's another job done. And we can now move on to the plastic bodywork, which is actually where I spent the majority of the time. Before we get on to that, just one other thing I had to do was the exhaust had failed, the end of it had snapped off, so I just made up a new stainless steel tail section. So that's the bit you can see poking down there. So okay, on to the bodywork. So all the bodywork was like this. You can see it's gone this kind of rough textured chalky appearance. It's not dirt. Normally the wheel arch sits over this section, so this is protected from the sun, but it goes like this. The sun degrades the plastic, and this is the vertical section, so it's actually not quite as bad as the horizontal sections. The roof and the bonnet were much worse than this, and the kind of I thought at first somebody had painted it with a stone effect paint, but it's just the plastic has degraded to the extent that the top surface, probably 0.5 millimeter deep, is just kind of turned to chalk. And this one I've already mostly finished. I polished it up, and the process starts off with a fairly coarse wet sanding disc. Strip it right down, take the lights out, sand it down to really firm plastic, solid plastic again. Some people try and use a heat gun to bring the plasticizers to the surface. I really do not recommend that as a technique for restoring plastic. While it will give a good appearance, or a better appearance, it will make the plastic really brittle. It's the plasticizers that give the plastic its flexibility and its durability. And if you bring those out, and that's effectively what's happened to this top surface. It's turned to kind of dust because the plasticizers have been boiled out. And if you bring the plasticizers from deeper down in the plastic to the surface, the entire plastic will go brittle and it will probably crack. So I don't recommend using a heat gun. It's harder work sanding it down, but it's a much better solution because the plastic that's left retains its proper qualities. So start off with a fairly coarse sanding disc, use it wet, sand it down, hose it off, sand it down, keep going until I get to firm plastic. Be very kind of grey, of course, it won't have a shine. Then go to finer and finer grades of paper, end up around 2000 grit, and then go to a plastic lapping compound, cutting compound. Go over it with that. Then a swirl remover. There's plenty on the market, usually used for car body work. Go over it with that, and then finally polish. It's a lot of work. I think this section took about 3 hours, but you can see the effect is well worth it. I didn't bother with this section. This again will be behind the mud guards, so I didn't bother with that, but you can see it comes up quite nicely, and it's not quite like new, but not too far off. And over time, as the machine's polished and cleaned, it will get even better. So on to the next one. I've already done the bonnet, got the other side to do, and then that will just leave the roof, which is the worst part. So the next thing to work on are the tyres. They're not terrible, but they're getting fairly bald. I had to put an inner tube in the front right. It kept going down, had a big puncture, and the inner tube was just temporary. But I have now got a new set of tyres, so I'll get these fitted. In fact, the back left tyre is on backwards anyway, so I'll get these replaced and we can move on. So that's all the tyres changed, a real motley collection that were fitted. The two front tyres didn't even match, they were different sizes. The rear tyres were initially the same size but very differently worn, so they were effectively different sizes, and the left hand rear was on backwards anyway. Some of them were dry rotted, so really needed changing. I've changed all those out. All four tyres are now fitted. Took about an hour and a half to change all four. It is quite difficult changing tyres like this, so heavy duty, very stiff tyres on small rims are always the hardest ones to change. But they're now on, and while I had the rear tyres off, you can see I've still got one removed. I wanted to address another issue. I previously mentioned that the speedo didn't work. Hopefully you can see some of this, but speedo didn't work, and one of the problems I've had with this was trying to find wiring diagrams. There are plenty of diagrams for this sort of vehicle online, but none match this machine. Some are close, some are not so close, but none exactly match what I was finding with this machine. So a lot of it's been guesswork, and what I eventually found, I'll just grab a torch, was tucked away under the fuel pump. I don't know if you can be able to see this. So down there you can see there's a white connector, so this connector here was tucked underneath the fuel pump. You couldn't even see it, it had been tied back. That turned out to match some of the wiring on one of the diagrams I had, at least the colour code of the wires did. And so I fed a signal into what I thought was the signal input going to the speedo, and sure enough that brought the speedo to life. And if 1 hertz was 1 mile an hour, up to 65 hertz was about 60 miles an hour. So that seemed about right, but the problem was where to get a signal from to feed into it. There was nothing plugged into that, and had a really good look, no speed sensors anywhere on the machine. But what there was, on the gearbox that we looked at previously, which is this thing down here, there's this output, hopefully you can see it, and this metal protuberance on the back of the gearbox is actually an output to drive a mechanical speedo cable. So if you look inside that, there's a kind of rectangular drive pin that rotates when the wheels turn. So I think there used to be a sensor in there, or there may have been a wheel sensor, but I think the sensor was supposed to go in there, got smashed, and no one ever bothered refitting it. So I ordered a sensor. The silver part you can see is not the actual sensor, that's an adapter I made to fit the sensor to the gearbox. So this screw here is a kind of locking screw, locks the whole thing in, and the 2 screws you see poking out that I will replace with grub screws hold the sensor into the adapter, and then the wire goes off to a 3-pin connector. Problem was I connected it up to the machine and it didn't work, and when I put a scope on it, it turned out that the signal output from the sensor just wasn't high enough. It should be 0 to 5 volts out, but it was only giving 500 millivolts. Cheap Chinese stuff, so seemed fairly pointless just ordering another one without being able to test it. So I decided instead, as it was reliably giving out that voltage, I made up this. It's just an amplifier, there's not a great deal in here. So as you can see, just a small piece of board with a few components. Very simple circuit, but it takes the 500 millivolts, filters it, obviously it's a vehicle, so there's a lot of noise on the supply, and filters it and then feeds that through to the speedo, and that brings the speedo to life, at least it should do. So we'll try this out. I'll get this plugged in and we'll fire up the machine, still jacked up so I can put it in gear, and we should see some activity on the speedo. Okay, that's now plugged in. I've cable tied the lead so it's not going to get caught on anything. So we'll try firing up the machine and see if we get anything on the speedo. I've reconnected the battery. So hopefully we're going to get something this time. That's the noise you can hear is the fuel pump. So I put it in gear, and what we're looking for is some movement of the speedo. And we'll try to get in high ratio, so it looks promising, it did move. Okay, clearly that's working. So I'll get the wheel refitted, and the machine is now pretty much ready to use. So it's been taken about 250 hours to get it into this state. It's in very poor condition. I've still got some work to do on it, but it should hopefully be quite a useful tool and save me having to carry things around or use a wheelbarrow.